Now in this second case, instead of applying the force on this bottom block, now I am applying on the top block, and everything is same as it is in the previous case. That is, the frictional coefficient of friction between B and A is mu s, and A is resting on smooth horizontal surface. But the difference, the only change is, instead of applying the force on the bottom block, I am applying force on the top block. Then what happens? As I told you, as this is resting on smooth horizontal surface, any minimum force can make the system to move together to the right direction. Therefore, acceleration of the system is given by A to the right is given by A is equal to total force acting divided by total mass of the system, capital M plus small m. Any minimum force can cause the system to move to the right direction. If there is no friction between B and A, and if I apply force on B only, then B only moves, A will be at rest only. But we assume that there is a friction between B and A. Now, in this case, when the system is moving to the right with this much of acceleration, what is the friction force acting between B and A? It is not limiting friction. Till the applied force reaches, which causes the body to slide with B with respect to A, about till we reach that point, the friction force between B and A is not limiting friction. So now I am going to derive the expression for what is the friction force acting between B and A in this case. So for that purpose, simply draw the free body diagram of B. What are the forces acting on B? Forces acting on B are applied force to the right direction. When the body tries to move to the right direction, A, out of its nature of friction, it will try to stop the sliding of B with respect to A, because of which friction force will be in this direction. This friction force may or may not be limiting friction. It depends on the acceleration of the system. Okay, so through this, what I can write: applied force minus frictional force is equal to mass small m into A. Through this, I wanted to find out what is the friction force acting in this case. That implies friction force F is equal to what I can write: small m into what is A? F divided by capital M plus small m. So F, I take this and I am sending this by this side, because of which we will be getting minus sign here, plus capital F. F is equal to, that implies, in this we can take F common. If we take F common, minus small m into F minus m into F gets cancelled, capital M into F divided by capital M plus small m. So this is the friction force acting between B and A in this case. But limiting friction is, as usual, always, but limiting friction acting is Fs is equal to mu s into small m into G only. Limiting friction is this one only, but the friction force acting is, in general, is F is equal to applied force divided by capital M F divided by capital M plus small m. Here I took already F common now, so this is not me. And next, what if, second point, what if the applied force is increased? Then what happens? The frictional force which is needed to support the motion of B also increases with the applied force. It keeps on increasing. At one particular value of applied force, it reaches the limiting value. So till that value of applied force, both the blocks move together. If the applied force is greater than that limiting force value, then what happens? They start sliding with respect to each other. Now I am going to derive expression for that maximum force, F max, up to which both the blocks moves together. Okay, so for this purpose, again I am drawing the free body diagram of B. I am drawing the free body diagram of B. What are the forces acting on it? Applied force is to the right direction, and frictional force is here. This frictional force is a limiting friction, because I am calculating what is the maximum force. Okay, so this friction force is limiting friction, which is to the left direction. So instead of writing the equation by using B, it is very easy to write the equation by considering the motion of A. So then what is the direction of friction force acting on A? Only force which is acting on it along the tangential direction is static frictional force. So as the friction force acting between A and B is static friction force, both the blocks moves together. So through this what I can write, Fs is equal to, what is that? Mu S into, normal reaction between these two is small m into G, which is causing the motion of A, because of which what I can write, capital M into A max. So therefore maximum acceleration of the system A max is equal to, what I can write, maximum acceleration of the system mu S into small m into G divided by capital M. This is the maximum acceleration that can be imparted to the system such that both the blocks move together. If you check this with our previous case, when the force is applied on bottom block, what is our observation? Maximum acceleration is not depending on any masses when the force is applied on bottom block. But when force is applied on top blocks, A max is depending on the values of mass of bottom block and top block. So this is a remarkable observation that we should keep in mind while solving the problems related to block on block. Okay, this is the observation. Here A max depend on the masses when the force is applied on top block, and corresponding force F max can be written as both the blocks move together, what I can write, F max is equal to A max into capital M plus small m. Therefore F max is equal to, what is A max? Mu S into small m into G divided by capital M into capital M plus small. This is the maximum force that I can apply on the top block such that both the blocks moves together. And next thing, third case that I am going to consider here is third point. What if the applied force is greater than maximum frictional force, F max? Then what happens? Body starts to slide with respect to each other, because of which frictional force that comes into the picture is kinetic friction, because of which acceleration of A and B will be different. So if you look at the free body diagram of B, F applied force is in this direction. In this, as the bodies are sliding, the friction that comes into picture is kinetic friction force. So because of which what I can write, applied force minus kinetic friction force Fk is equal small m into acceleration of B. Why I am writing acceleration of B? Once they start to slide with respect to each other, their accelerations are not same, they will be different. So that's why I am taking acceleration of B as AB. Therefore acceleration of B is equal to, what I can write, applied force minus what is kinetic friction force, mu k into small m into G divided by small. This is the acceleration of B. So if we draw the free body diagram of A, here we will be getting acceleration of A. Only force which is acting on A is Fk to the right direction. So what I can write, Fk is equal to capital M into acceleration of A. Therefore acceleration of A is equal to, what is Fk? Mu k into small m into G divided by . Here there is one thing that we should observe. In previous case, that is when the force is applied on the bottom block, acceleration of B is mu k into G. For any value of applied force greater than F max, it is constant. It is locked at mu k into G. And acceleration of A keeps on increasing with applied force. But when the force is applied on the top block, what is happening? Reverse is happening. What is happening? Acceleration of A is locked down. That is, acceleration of the bottom block is locked. It is constant. But acceleration of B keeps on increasing. These are the things that we should keep in mind while solving the problems related to block on block. Thank you.